Good morning and welcome to today's lesson. Welcome to Ambassador Speaks YouTube channel lessons, where we inspire, where we make sure that you reach your potential. Our motto is your dream is calling you. I want to take this chance to invite you for these midterm lessons, whereby we are going to have chemistry lesson daily from 9 a.m. and physics lessons daily from 5 p.m. in the evening. So today, I would just like to confirm whether you can hear me. I just want to confirm whether you can see what I will be writing on the board. My name is Mr. Mayo. Others call me Mr. Alex. I teach at the Alliance High School here in Gikuyu. And I will be engaging you most of the times in these lessons on chemistry and physics. Also, apart from this, I would be taking you through, you can still check in my channel, whereby I've been doing some videos on inspiration, motivational talks, videos that matter in your life. I've been talking about areas that you really need to hear and you really need to apply in your life as a parent, as a student, as a business person, as a teacher, and I mean, all-rounded talks in our channel. So you are free to visit it at any time. You are free to be there. You are free to watch the videos. You are free to comment, share, I mean, subscribe, and invite as many people as possible to board on this moving vehicle that is the Ambassador Speaks. So today, I want to talk about a topic in chemistry that is known as the carbon and its compound. This topic is one of the industrial topics. We have actually 4, by extension 5, industrial topics. So we have carbon and its compound in form 2. We have nitrogen and its compound in form 3. Sulfur and its compound in form 3. Chlorine and its compound in form 4. Another part that behaves like an industrial topic is air and combustion in form 1 and water and nitrogen, because there's a bit of manufacturing. When we talk about industrial, we are talking about we were just talking about the topics that has something to be prepared or to be manufactured. So as I'm moving on, let me know, where are you watching me from? Is my audio very much audible? That's what I'm asking from you before we embark on carbon and its compound. I wish you all the best as you are yet to understand this topic. So chemistry topic. So look, if you are seeing what I'm writing on the board, carbon and its compound. If you can see what I'm writing on the board, just give me a good comment. Yes, I can see what you are writing on the board. Though today I'm going to write very less. I'm going to speak more than what I'm writing. But tomorrow, when I will be now doing the other parts of carbon, that is preparation of carbon dioxide, preparation of carbon 2 oxide, when I will be talking about sulfate process, those are the times when I will need to write more. But for today, I will be speaking more than I'm writing. So I'm just asking a very simple question. Where are you watching me from? That's a question. And which school are you? Yes. So once again, I invite you to carbon and its compound. And this topic is a very nice one. Yeah. So welcome on board. Have a book. I always say this, even when I'm doing the other things, when I'm just, I'm doing my, theater talks, I always say, have your notebook in place, such that you will be writing what needed to be written. So, carbon and its compound. First of all, as I'm starting, ask yourself, which part of the periodic table is carbon found? We are starting from there. Which part of the periodic table do we find carbon? I'm checking on the, I'm opening it somewhere. I'm opening the video so that I can see what people are saying, because you have refused to make a comment on whether I'm audible or not. In fact, I wanted to see how the board is, whether it is clean or not clean, but I've seen it is very clean. Now, let's come back to our lesson now today. Carbon is atomic number 6, and therefore its electronic configuration is 2:6. is to 4. So it is found in the group 4 of the periodic table. We start from there. Now, we always say that an element can either lose or gain electrons. Now, for carbon, it can gain or lose. Yes, because what determines for an element to gain or to lose electrons is the number. If it's supposed to gain more to be stable, like element like aluminium, it has electronic configuration of 283. So it can either lose 3 or gain 5. So it's just like an algebra. 2x and 4x. 2x must go where the 4x is. So it will lose less than gaining more. So carbon, it can either lose 4 or gain more. Now, depending on the element it is reacting with or forming a compound with, because elements lose electrons or gain electrons when they are reacting, or simply when they are forming compounds with other elements. Now, when carbon is forming a compound with oxygen to give us carbon 4 oxide or carbon 2 oxide, automatically carbon is going to lose. But when carbon is forming a compound with element, for example, calcium, to give us calcium carbide, then automatically it is the one that is now going to gain. From what? From calcium. So that's a brief view of carbon. And in terms of bonding, carbon forms covalent bond. It uses the outermost electrons to form covalent bond. Now, there is something I want to talk about when it comes to carbon. Carbon forms what we call allotropes. Allotropes. There are 3 terms that mostly confuse students. One, isotope. You tell a student to define allotrope. The student with this common sense and define isotope. Then we have the other term in Form 3 again known as isomer or isomerisms. That's another term whereby, kidogo, it may bring a confusion, but don't confuse these things. They are very simple and you need to know how to tackle them. Allotropes. Now, these are elements. Like, they have the same physical appearance. They are of the same physical state, that is. But when you look at them or when you feel them using your fingers, they are different. In this case, allotropes of carbon are 2. We have 2 main. This one is diamond. Diamond from Tanzania. Then we have graphite. Graphite is everywhere. Graphite is the one that is used to make pencils. These ones are pure allotropes. They are the main or the pure allotropes of carbon. Now, diamond is a carbon, graphite is a carbon. They appear very different. Of course, the 2 of them are in a solid state. But they are different when you see them and when you feel them. But the truth of the matter is the 2 of them are carbon. Now, carbon also exists in other forms. Like apart from diamond and graphite, there are others, we call them the impure states. For example, amorphous carbon, fullerenes, and the normal charcoal we use at home. You know them. These ones are the impure forms of carbon, the 2 pure forms of carbon. In fact, that we are going to discuss and spend much of our time in is the diamond and the graphite. These ones, we are going to see them. Just to share with you, like one difference between the 2. Carbon is a non-conductor. We call it an insulator. It does not allow electrons to pass through, or it does not conduct electric current. Graphite will do so. I'm just starting from there. That is my pickup line. Like diamond does not allow electric current to pass through. Graphite allows electric current to pass through. Start from there. Why? Because in chemistry, you must explain using scientific terms. Why is graphite able to allow current to pass through while the, what do you call this that one? The diamond does not allow? What is the difference, or what is it that you think as per to those differences? Now, my point is here is, what conducts current is electrons. Now, all of them, that is carbon and diamond, they have 4 valence electrons at the outermost energy level. All of them have 2,4. All of them have 4 valence electrons. But now, the way the bonding is structured is so different that in graphite, there is an electron left for conduction of current. In diamond, it uses all the 4 electrons such that there is no one left for conduction of the current. Did you hear me? So all this is a matter of is there any electron that is there to be used for conduction of the current? If yes, then it's a conductor. Now, graphite is a conductor because the bonding is in such a way that there is one electron left to conduct the current. In diamond, it uses all the 4 electrons in bonding. Remember, they have what we call covalent bonding. Are you together? So now, what is there again? Yeah, I was just looking at some of you. There is someone called Nimo from Naivasha, and nasoma Naposha Girls and shifting grades on online schools, anasema let's follow Sir Alex Kipruto. Thank you so much for that. Now, let's proceed and let's look something more here. I hope I'm okay, I'm audible, I'm doing on well. So let's look at some of the features of, can we start with diamond or with graphite? Your case is as right as mine. We start with any. So what is allotropy? There are 2 terms that I want you to differentiate here. There is difference between allotropy and allotropes. So the existence of an element in more than one form in the same physical state is known as allotropy. Elements which are in the same physical state but different forms are known as allotropes. The process of existence is what we call allotropy. I hope you can hear me. Now, we have 2 main. And remember, please don't forget this. The 2, which is diamond and graphite. The 2, they occur naturally. This one, they occur naturally. They're not man-made. So. They're not man-made. The only man-made we know is the diamond, the person who is singing, is a man-made. Yeah, tunamujua is a man-made person. Yes. Now, let's talk about the diamond. Where is my duster now? Yes. So, tuangalie, there are always 4 questions that you need to ask yourself about diamond. Anytime you get to ask yourself about diamond, there are only 4 or 5 by extension, that is. If you're able to answer the following, then you will be okay with the diamond. First of all, to answer a physical appearance. How does it look like? Actually, it doesn't have a specific color. We call it colorless. It is shiny, colorless, crystalline, solid. From each property I'm giving you, there is a use. I'm saying this. Shiny, crystalline. What does it mean? If something is shiny and crystalline, what is it being used for? It is used in making of the ornaments and bangles and, such things for beauty because it is shiny. Now, diamond uses all the 4 valence electrons in covalent bonding. After using all the 4 valence electrons, there is none that is left. Therefore, diamond does not conduct both heat and electricity. I hope I'm keeping you clear. It does not conduct heat and electricity. Why? Simply because there is no electron left. It uses all of them for bonding. And the type of bond, tumesema ni covalent bond. Therefore, now, another question. So, those are 2. I've given you the physical properties. That is, it's colorless and shiny crystalline. Number 2, I've said this. It does not conduct heat and electricity. And I've given you the reason. Number 3, now, it has a very high density. Actually, the density of diamond is around 3.51 grams per centimeters cubic. This is a very high density compared to that one for the allotrope. Allotrope iko chini kidogo. Sorry, for the graphite, tutaangalia after this. This is a high density. Now, you are supposed to give a reason why it has a very high density. I mean, what has brought to this high density? It is because of the continuous close packing of the carbon atoms. The carbon atoms are very close and it happens continuously. The close packing happens continuously. So, what can we say? it is having a very high density. Tumejibu hiyo. Another thing is, it has a very high melting point. You also need to answer this. High melting point of around that 700. Though graphite also has a very high melting point of around that 500 degrees Celsius, this one is having a very high melting point, 3700 degrees Celsius. Kama ile maji ya ugali yenye unapikanga na ugali kwa nyumba, mkono ikishika hiyo maji hivi kidogo, trust me, like inaweza toa ngozi. Unaingiza, ukitoa mkono, like you are flying in the air. Hey, very painful. Now, what now, just imagine 200 degrees Celsius, 300 degrees Celsius. Kwanza, when you put your hand, not even water cannot reach 300 degrees Celsius unless under very high pressure. When you put your hand this way, at 500 degrees Celsius liquid, ukitoa, hakuna kitu unatoa, like mkono imeishia huko ndani. Now, just imagine that 700 degrees Celsius, very high melting point. Why? It is because of a strong covalent bond. That's the simple answer. Strong covalent bond. Strong covalent bond. So now, let's proceed. Let's look at other properties of diamond. Diamond is one of the hardest known elements. Very hard. In fact, let me write here. Very hard. Very hard. Like, it is hard. By the way, when I was young like you, I used to think that metals are the hardest. And you get the word chuma. In fact, I didn't know that, it was until later on I realized, oh, so the name metal, for me, I used to think metal means hard. Like, I was a village boy, like, metal ni kitu, mimi nimezoea metal ni kitu mzito, kitu inakata isingine. Metal is not hard. Diamond is hard. Just a minute. Naomi. Morning, how are you? Yes. Yes, ako nazo. Ako na credentials, everything. Wapi kwa namba yangu? Normal text, yes, ndio. Aya, sawa. Check WhatsApp, sorry for that. I'm handling some things about State House. Kuna vitu za State House na handle kidogo. Wacha nitume wananiuliza tufanyaje, like what can we do. Sasa nataka niwaambie wacha watu wa demonstrate. Msiwaambie anything, people should be allowed to demonstrate. So I'm saying that diamond is very hard, and because of its hardness, it is used in cutting other metals. It is used in cutting other metals and other hard materials. So, by the way, there are some metals which are liquid, like mercury. Kuna student wangu nilimuuliza, what's the state of like mercury at room temperature? Ananiambia gas. Kaambia kwende huko kabisa. It cannot be a gas. It is. Yes. Hello. Nimekutumia WhatsApp, check WhatsApp. So, sorry for that. Now, ukiangalia, if you want to cut a very hard material, use diamond. Why? It is also very hard. That is about hardness. And why is it so hard? It is hard because of the uniformity of covalent bonds between the atoms throughout the structure. Uniformity of covalent bonds between the structure throughout. That is the reason why it is very, very hard. Now, what is the structure of diamond? From bonding, we get the structure. Kuna topic, the previous topics, structure and bonding. The bonding determines the structure. Like in ionic bond, we will get giant ionic structure. In covalent bond, we have two, molecular structure and giant atomic structure. Now, diamond is having what we call giant atomic structure. Very strong structures. Now, what is the shape of diamond? Okay, from the structure, which shape does it give us? It gives us what we call tetrahedron shape, regular tetrahedron shape. Kevin anasema brains at work. You remember you were my desk mate once, Kevin, tukiwa hiyo shule tulikuwa. Anyway, Chebara Boys was one of the best schools, I would say. Hata next time, if I want to go, if I'm told to go to high school again, I will still go to Chebara Boys. Kevin is a friend of mine who is alikataa kuwa mwalimu akaenda akakuwa nurse. And I'm happy for him. Let's proceed. What was I saying now? I was saying this, that you know, structure gives us the shape, the arrangement of the atoms, the arrangement of the molecules. It also determines the hardness of a substance, and there's no problem with that. Now, that is about diamond. Now, let me give you questions. Let me, the 4 questions I told you is, number 1, the shape of the diamond. Tumesema ni tetrahedron, regular tetrahedron. Diamond is hard, give a reason why it is very hard. Diamond has a high melting point, give a reason. Diamond does not conduct electricity and heat, give a reason for that. Diamond is shiny, give a reason for that. Now, diamond, because of its shiny appearance when polished, it is used as a jewelry. You know, when we talk about jewelry, I think that is the spelling. But how do you pronounce? You pronounce as jewelry. Just pronounce it very well. Jewelry. So why is it being used to make jewelry? It is used to make jewelry because it is shiny. yes, when polished. There was a day in another school I was sometimes back. The principal called, the students who refused to perform, he called them diamond. Why? Diamond is one of the best. It is shiny, but you cannot see the shyness unless you polish, unless you grind, unless you clean it, you wash the outer cover. When you wash it, you will see that it is shiny. Most people are behaving like diamonds. They shine inside, but not outside. I'm saying this, I will polish you, and then you shine like diamond. Now, diamond, because it is very hard, it is used in glass cutters and the drill bits because of its hardness. Now, do you have any question about diamond? You can ask me. Do you have any question about diamond? You can ask me. If you have any question about diamond, please ask me or I answer you. Now, I wanted to go to graphite. We are still dealing with the allotropes of carbon. And of course, I am believing and I'm praying to God. You know how to define the term allotrope, allotropes, and you define the term allotropy. The 2 are different. One is the existence of, one is actually the actual definition. My question is this, please, those who are in, can I really get where you're watching me from? Please tell me where you're watching me from. Like, where are you watching me from? Which school are you? I will be very happy to hear that. Please represent your school and the name of your chemistry teacher. In the evening, when you will be having chemistry at 5 p.m., also represent your school and your physics teacher. I really wish nipate mwanafunzi wangu hapa. Kuna mtu anasema I can't see on the board the sunlight. Oh, sunlight. Is it really sunlight? No, but don't worry. I am writing less here. I will be writing very less things here. That is Gloria Wamugona. But I'm writing a very less Gloria. Gloria Agoma Mangina. Thank you, Gloria, for Wawugoma. Who is your chemistry teacher, Gloria? You say you cannot see the board? Like, say, waje kiniandika hapa. Like, Gloria, nimeandika your name on the board. Can't you see your name? Yes. There's no problem with that. Let's proceed. Please let me. Oh, by the way, there is a change in the lighting system. But Please, shifting grades, confirm you can see my screen. Confirm that you can see my screen so that you proceed with a lot of confidence. Yes. Let's look at graphite now. Tumemalizana na stories Diamond. But if you have a question about Diamond, please, your best chemistry teacher in the world is here. Wait, I don't believe there is somebody who is better than me. Also believe in yourself. I'm just saying that like whatever you're doing, you're one of the best people to have ever existed in this world. The problem ni kutojiamini. Kujiweka in a position that you feel somebody else is better than you. You are one of the best things. If I have to use things, you're one of the best people. You're one of the best creatures. You're one of the best creation of God to have ever existed. If you're walking, ensure your head is held high. Your hopes are alive. You walk like you own the whole world. Of course we own, because our Father is the owner of the whole world. Anyway, graphite. Now, graphite is another one. Like, it's another stable allotrope of carbon. Gloria, have you seen your name? Maybe I will know how to deal with the lights. But for now, if I start doing that, I will waste time. So in the evening lesson, in fact, the light will be opposite from where I am right now, and it will be the best. So don't worry. We are going to have a very nice lesson. And I said I'm going to write less. Graphite. Now, this one is black. It is very soft, and it is slippery. Soft, slippery, and of course black. I had a pencil here, but don't worry. Pencil is made of... Okay, nisawa, imepotea. Pencil is made of graphite. The inner part, black, it's made of graphite. It is black, and you know. When you write it this way, it slides in a slide, leaving a black mark, which can be erased using a rubber, of course. That's graphite. Why is it being used to write or to make pencil? Because it is black. Okay, to know black, because even if it was green, as long as it can slide and write, it's okay. So because it slides, leaving a black mark. Sliding means you don't struggle. Yes, and it is slippery. That is one of the points that you need to know about graphite. So it is used to make pencils because it is black and shiny. So now, please, those who are watching, I'm asking a very simple question. Where are you watching me from? Network imeanza shida? No. I don't think so. It's doing on well. I hope. Let me just check. Open network haitanilete shida. Gloria, is it doing well? I'm about in a rotate. Because mine is rotating. I don't know what could be the problem to this. Just a minute. So graphite. I hope now I'm... Okay, let me confirm. If you can hear my sound, please andika, because there is something lying to me that it's not doing well. But me nikiona it's functioning very well. Anyone on anyone on kwa Ambassador Speaks YouTube channel, please just confirm that you can hear me. There is something telling me that the network is having a problem. Is it true? Anyone, just write tell us it's okay. I like to proceed. I'm waiting for that confirmation. I don't know why my laptop is misbehaving. Even if it misbehaves, I don't care. We will have to proceed. The shape of the graphite is hexagonal. 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 Yes, it's hexagonal. Now, anyway, now let me talk about the bonding. Out of the 4 valence electrons, it uses how many? It uses 3. After using 3, one that is not used is the one that is used for conduction of current. That is the one that is used in conduction of current. Are you together? Now, that is the reason as to why graphite is used in conduction of, as a conductor, or why it conducts electricity. By the way, let me take you back kidogo to just a minute. Graphite is used as an tuende pale kwa effects of electric current on substances. Graphite is used as an electrode. Why? It is inert, and of course, in example, inert, I mean it does not react with the other substances. So it is inert, and it is very cheap. By the way, pencil can cost even 5 shilling. A pencil can cost 5 shilling, and there's no problem. And after costing 5 shilling, you don't care about that. Sawa. No one says I can. Of all the names in the world, no one. Anyway, no one can hear me. No one can hear me. There's a person called no one who can hear me. Yes, I'm just saying that way. Anyway, now the density of graphite is 2.3. What did I say is the density of diamond? How? 3.51. Now, why is it having a low density compared to the diamond? It is having a low density because of the spaces between the layers. It has some spaces. It had a very high density because there was close packing of carbon atoms. This one, there is spaces. That's why the density is low. It is also soft and slippery. Why? Why is it soft? Something soft like this. Upper gonna sofa set, very soft. So it is soft because its layers can slide over each other when pressed. Like if it has 2 layers like this, when you press this, it will slide on the other one. That's why it is slippery. Yes. And why is it so? Because between this layer and this layer, it has a weak van der Waals forces. Between the atoms themselves, ni covalent bond. But now, between the layers, ni weak van der Waals forces. So they can easily slide over each other when pressed. Now, anything else about graphite? What is graphite used for? By the way, melting point is at 500 because of the strong covalent bond. That 500 what? Degrees Celsius. I hope hapo tuko pamoja vizuri. That 500 degrees Celsius. So why? Strong covalent bonds. Now, diamond, not diamond. By the kuna mtu jirani alikuwa ameweka ngoma ya diamond. Ndio maana akili inaongea diamond. Mimi si fan wa diamond. Now, I'm saying this. Graphite is used as a lubricant in moving parts of a vehicle where a lot of heat is produced. The keyword is where a lot of heat is produced. Lubricant is that substance used to reduce friction in moving parts of a vehicle where a lot of heat is produced. When you are asked this question, in moving parts of a vehicle where a lot of heat is produced, you must know that they were actually targeting. In its structure, we have one delocalized electron that is used in bonding. Now, any question that you have with me? Any question that you want to ask me? Kama iko. So, it is used in making molds for casting metals. It is used as an electrode, and there are 2 reasons why it is preferred over others. It is preferred over others because 1, it is very cheap. Number 2, it is inert. And of course, it's a conductor like any other. First of all, for a substance to be used as an electrode, it must be it must it must be a conductor. Then the other factors comes in. Inert means it does not react with the electrolyte. Then number two, very cheap, something that is not costly. Yeah, hatutakangi vitu expensive. I forgot to tell you where diamond is found. Let me go back kidogo niwaambie where diamond is found. Ndio nikuje nikuambie where graphite is found. Nobody will ask you this in history. Hii si ya chemistry. Where diamond is found is not chemistry. But it's good to know where diamond is found. Of course, now, South Africa and Tanzania. Tanzania kuna diamond mara mbili. Kuna diamond na mineral, na kuna chama anajitanga diamond. Aya, where is graphite found? Ladies and gentlemen, where is graphite found? The best football team, the best country on football. Okay, someone is telling me to draw the structure of graphite. I will draw right now after Nemema's statement. I'm saying this. The best... what am I saying now? The best country in the world in football. It is not Argentina. It is not it's not Spain. It is not Portugal. It's not England. It is Brazil. By the way, Brazil is the only country that has never missed World Cup since it started. The others have missed. And the others, like Kenya, they have never gone to World Cup. I love Kenya. Sina ubaya na Kenya kabisa. Brazil is where graphite is found. South Africa is where graphite is found. Sweden. By the way, when I was young, I used to say, I want to go to Sweden. There was a footballer from Sweden. I don't know what was his name. Alikuwa na jina funny kama tongue twister. What was that? Anyway, I saw him in World Cup 2010, South Africa. But anyway, I will go to Sweden one day. Then Germany. Germany also has some deposits of graphite together with USA. So I've said USA, Germany, Brazil, South Africa. And of course, Sweden. These are where it is found. Now, I'm done with those. Someone is saying that we can give a structure of graphite. So that after nimemalizana na graphite na diamond, now I will talk about the impure forms. The impure forms. Now, I will try. I'm a very poor artist, by the way. Lavender, you will confirm whether whatever I'm drawing on the board will be feasible. I will try. Ikinishinda, I will call my brother to come and draw it. So we have this. Even the pen itself is refusing. Trying to save me from... Someone to confirm that you can see this one. Then, ikisha kuwa hivyo, hii pia inaenda, hii inashikana na ingine hapa. And of course, inaenda hivi. Wacha kwanza niangalie if each one of them has 6. 1 2 3 4 5 6. 1 2 3 4. Hapana. Kwanza hii ilifaa iende like after imetoka hapa, which is this one, iende mbele kidogo hivi. Then ikishafika hapo, hii kwanza iende straight hivi. Then ikutane na ingine hapa. Now, it is the upper part. Then we have the lower part kama hii exactly. Another one like this. So this is one layer. So we will have another layer like this hapa chini na ingine hapa chini. Then in between these layers, we have what we call weak van der Waals forces, which slide over each other when pressed. Can you see the port? Hey, why is it rotating now? Is it network again? Can you see my boat, Lavender? Let me draw. So you see the way it is. Then between these we have weak van der Waals forces. The process continues. So ini weak van der Waals forces. Which when you press this layer, it slides over this layer because of the weak van der Waals forces. Hope you can see what I've just written on the board, and yeah, thank you. So that is the structure of the graphite. That's how it looks like. That's how it behaves. Let me check on the other side on the shifting grades. From shifting grades, let me see if there's anyone having a question on the shifting grades. Shifting grades. By the way, shifting grades are also my friends from like shifting grades is a channel for my brother, and we are doing it together when we are working it together. So if you're watching me using Ambassador Speaks, baadaye go and join shifting grades. So utaona some lessons there. And for those who are watching me using shifting grades, please come back to Ambassador Speaks. Then see chemistry lessons there, physics, and many other talks, as I said at the beginning of the lesson. So I'm trying to see kama kuna mtu akona swali kwa upande wa shifting grades, because the one I can monitor here, I can monitor Ambassador Speaks. Yes, someone is asking, do you have a physics lesson? I said yes, at 5 p.m. in the evening. Seirion Lebarero, Alliance High School to S. Thank you so much. Wewe uko sawa. Tutakutana shule. Nimo anasema I can see. Julia Kingori anasema I can see. Gloria still anasema I can see. By the way, members from shifting grades are very active. Wangu wa Ambassador Speaks apart from Lavender, Sarion, no one, most of them, they are not so much active. I want to talk about something else. Which is I want to talk about fullerenes. You know, the pure forms ni mbili, diamond and graphite. And nimesema it's much of history, but of course tomorrow I will be moving very fast. Tomorrow now I will kesho nitaenda mbio. Kai, umujui. So make sure you join at exactly 9 a.m. to move back at 10 a.m. In fact, right now I have only 7 minutes to conclude the lesson. So don't worry about that. Now, let me talk about fullerenes. I said, tell me where you were watching me from, and school, and your chemistry teacher. Yes, so I got to finalize by just mentioning that apart from diamond and graphite, we have others such as fullerenes, amorphous carbon. Yes. So that is it. So fullerenes, they are synthetic. Just notice they are synthetic allotropes of carbon. They have various shapes, very many shapes, like elliptical, spherical, tubular. Like it exists kama tube kama hii. We call it a tubular. And then one of the best known fullerene is fullerene spherical C60. Like it's made of carbon 60. 60 atoms of carbon molecule. That is as fullerenes we know. Kama tu imekaa kama mpira ile ya kuchezea football. Then we have another one known as amorphous carbon. Amorphous carbon is not so much common, but it is man-made, kama charcoal, kama coke, kama soot ni ile ukiwasha moto kanashikanga nyumba pale juu. We have coal is naturally occurring especially in South Africa. It has very small amount of graphite, like ukishika makaa unaweza andika ukuta yandike black, iko na small amount of graphite, but of course they are not very slippery. They still, just like graphite, they do not conduct heat and electricity, because of the irregular arrangement of the graphite crystals in their structure. Like it cannot conduct electricity. Now, carbon is charcoal is amorphous carbon. Charcoal, it has a property known as adsorpbility, or it adsorbs. See, absorb hapa ni D. It adsorbs colored impurities. Ukiweka mahali kuna color, inachukua color. It adsorbs colored impurities in sugar refining industries. It can also absorb gases and liquids. It is used, therefore, in gas masks. Amorphous carbon, charcoal specifically, is used in gas masks because it absorbs gases and liquid masks. Yes. Why are tires of a vehicle black? Why are tires of a vehicle black? If we can ask ourselves, why are the tires of a vehicle black? Because carbon black is mixed with rubber in the manufacture of tires. That's why it is black. Now, tomorrow we shall be looking at what we call chemical properties of carbon. Chemical properties of carbon, starting with burning of carbon in air, writing of chemical equations. Now, tomorrow we shall move very fast, and we shall utilize the board at the most. So what am I saying now? Today was the introduction, but I want to ask you to invite your schoolmates tomorrow. So, kuna mtu anaitwa where is his name now? Mepotela. The one from 2S. Do this. Invite the other members from 2. Let them join us in the evening and tomorrow. Otherwise, I would like to stop there for today. If you have any question, please ask me. My phone number is 0796 262471. Wacha nifuta hapa niandike phone number such that in case you have any question, anything, you want to buy me credit, do it. 0796 26 24 71. This is Mayo. Yes. That is where we are. Good. Otherwise, I want to wish you all the best as you are pursuing your academics. Your dream is calling you.